for polar coordinates. Now, your calculator is going to be crucial for this because I'm going to show you some neat tricks. Because once you get some of the harder ones, calculator is going to be beneficial for this. Converted between polar and rectangular. Wow, oh, it was hard to find that word. Okay, so plot points using polar coordinates. First, polar coordinates start with R. So, and then it has your angle that it's going to go. Pull this up so I don't screw it up. So my first number is going to be R. The next one is going to be my angle. So they're a circular type of function. So my radius on this one is 3. 1, 2, 3. And it's going 5 pi over 8. So So 5 pi over 8. So that's going to be more than, yeah, so it's going to be a quadrant 3, right? Yeah. So it's going to look something like this. Down to right here. So that's what we're going to have there. No, 5 pi over 3.
That's what I said.
I thought you were saying quadrant 3. Sorry. You need to speak up, man. Seriously. I don't know what I'm doing here. Alright, so 5 pi over 3 is, so 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Alright, so let me see. There. 5 pi over 3 should be right about here. So my radius of the circle is going to be 3. So it's going to go around 3, and then my angle that it's going to travel, which is goes from here to here, all around, that's my 5 pi over 3. So what would be another way of saying the same one? Instead of saying 5 pi over 3, what else could I say? Yep, negative pi over 3. Yeah? Okay. I think I have a graph. I think I inserted a graph in the next one. Did I insert a graph on any of these? Oh, there it is. Okay, here's my graph. Okay, so what was the next one? What was question B?
2 negative pi 4.
All right, so my radius is 2, and negative pi over 4, so that means it's going to be right about here. So it's going to go here. So it is 1, 2. There we go. So it's going to be that right there. Not bad? Okay, what was the next one?
3 and 0.
3 and 0. Okay, so it goes over 3, and my angle is 0. 3, and angle is 0. And what was the next one?
Negative 2 pi fourths.
Negative 2 and pi fourths. All right, so if my radius goes this way, negative 2 would go this way, right?
Mm-hmm.
And it's traveling which way?
Pi 4.
Pi over 4. So pi over 4 is going to be right here. last one?
Yeah.
Alright, there's another way we could have done this one. So, it gets us in the same spot, but it's a different way of actually graphing it. But if I were to graph the positive would have put me here to here, right? That's the positive. And going the negative radius would just put me 2 in the other direction. So it puts it there. Negative radius just goes the opposite way. Does that make sense? Okay. All right. Clear that one. Okay, we got all those. All right, so plot the point P whose polar coordinates are here. Find 3 other polar coordinates of the same properties. So if R is going to be greater than 0 and theta is between 0 and 2 pi. Okay, so another way of doing this, so let's take a look. So if I say is supposed to be, let me see, that's going to be a negative 3 pi over 4, which is going to put it this way, right? It's going to go right here, and it's going to go a radius of 2. Yes? Say yes.
It's in a negative 2.
Hold on.
Or yes.
Because it's going 2 this way, right? So I did this piece first. Yes, did this piece going this way first, but I went 2 this way, right? But if I want negative 2 now, it needs to go back this way. There we go, right there. So it goes there. That's going to be my negative 2 over here, isn't it? Yes? Okay, so now rewrite it using r is greater than 0 and theta is going to be between 0 and 2 pi. So how can I rewrite that now? So if this is 3 pi over 4 to here, what's this one over here?
Pi over 4?
Yeah, pi over 4. That's going to be pi over 4. And my radius here would be 2. Does that make sense? Please speak. Or forever hold your peace. Are we good? B? Okay. What's the next one?
So the radius has to be positive.
Yeah. Find 3 other. Okay, so now for B, if I were going to do the same thing, radius is going to be positive, right? So I'm going to erase what I have for this one. So this is supposed to be, there we go. Okay, so next one, radius is going to be positive again, right? And it's going to be from negative 2 pi to 0. So how would I measure it this way now? I'd go all the way this way, right? So what would that give me just to get to there? What would my angle be all the way to there? We said this is positive pi over 4. What would this all the way be? Yeah, negative 7 pi over 4. So negative 7 pi over 4. Right? And for my radius to be positive, so it goes negative 7 pi over 4, and then I have what? Positive 2. Yeah? Okay, so let's do another one. And now this one, my radius is going to be negative. Let me just clear this up. circle again. I'm supposed to end up right over, so going that way, so, and that's 2, and this way is -2, so. Now, if I want my R to be negative and my theta to be positive, how would I make my theta positive?
Bring it to the third, or the,
Third quadrant, right? Okay, so you're saying going this way?
yes.
Go this way, and then have the negative radius, right? So, what would my angle be there?
5 pi over 4.
5 pi over 4. And my radius would be?
-2.
Okay, all right, good. Point P with polar coordinates r theta can be represented by r and theta plus 2 pi, or 2n pi. That means it's basically it's coterminal. It's going to be adding another whole revolution back to that spot, right? So it's whatever my angle is, add 2 pi is going to give me my next one. And however n times I go around. Or, if this n is an integer, so from negative, I could do the same thing from a negative. Polar coordinates of the pole are 0 and theta, where theta is any angle. Polar coordinates to rectangular, P is point with polar coordinates r theta. Rectangular coordinates xy of P given by x equals r cosine theta, y equals r sine theta. All right, so let's go ahead. We're going to turn these into, so the x value is r cosine, y value is r sine. So it's going to be r, which is 4 cosine of pi over 3, and then it's 4 sine of pi over 3. Cosine at pi over 3 is going to be 1/2. Yeah. So 4 times 1/2 is 2. And this is going to be rad 3 over 2. 2 times, so it's going to, 4 times that, so it's 2 rad 3. And this is going to be in my rectangular coordinates. So let me show you the difference between polar and rectangular. A polar starts with r and theta. So I have a radius, and then I go over a certain amount of my angle. This says I have 2 in the x value, 1, 2. I go 2 rad 3 in the y value, so it should be right here. So this is what my graph is in rectangular, where I know it should be a radius of 4 would get me to here, radius of 4, and it would go up pi over 3. That's what that means. So right here, this angle is going to be pi over 3. And the length of this arm right here is going to be 4. So rectangular and polar are the same spot. It's just a different way to show it. Does that make sense? All right, let's try the next one then. Actually, I want to see you guys try the next one. You guys try this one. come up with that? Rad 2 comma negative rad 2? Yeah, good. Okay. All right. Do we need to finish this last one? Basically all the same thing, right? Okay. And convert rectangular coordinates to polar coordinates. P is any point in the plane rectangular. Okay, we got to solve for R. And then to get my theta, it's going to be inverse tan. So it doesn't say it here, but theta is actually going to be inverse tangent of y over x. Because you want to know what theta is. You don't want to know what tan theta is. You want to know theta, because you have to have theta, right? Okay, and there's a neat little trick you could do with this. If your calculator is in degrees, it will spit out answers for you correctly. So instead of saying pi over 3, your calculator will give you a decimal if it's pi over 3, right? But if you have your calculator in degrees, wouldn't it just say 60 degrees? Yeah, that would just say 60. And then you would say, oh, 60 degrees is pi over 3. So that's a neat trick to go along with that. So that's if you have your calculator and you use it on these. Okay, so R, basically Pythagorean theorem just to solve for this. All right, find polar coordinates. So first, R equals square root of 4 squared plus negative 4 squared. R is 16 plus 16 is square root of 32. And that's going to give me 16 times 2? Yeah. So it's going to be R is equal to 4 rad 2. Okay, so there's the radius, and now let's find theta. So theta equals inverse tangent of y over x, so my y is negative 4 over 4. So that means that's going to be in quadrant it's going to give me negative 1, right? And so, so negative y quadrant, right? So negative y, positive x, and where is the x and y the same?
Third quadrant.
Quadrant 4.
Yeah.
It's quadrant 4, and it is negative pi over 4. Negative pi over 4, or what else could I call it? 7 pi over 4? Yeah, 7 pi over 4. So either way, I'll actually get both of them being the same thing. So negative pi over 4 or 7 pi over 4. So but as you notice with the polar coordinates, you could actually use negative or positive depending on what it's asking for, but it's going to give you the same spot. All right, so this point would be 4 rad 2 comma, let's say negative pi over 4. Are we good there? Yeah? Okay. All right, let's do the next one. So R is equal to square root of negative 1 squared plus square root of negative 3 squared, which is going to be 4. R is 2. Theta inverse tangent of negative rad 3 over 3 divided by negative 1. No, why did I put over 3? Sorry. Should be just negative rad 3 over negative 1. There we go. Okay. So if I'm looking at my inverse tangent and thinking about it, I need the y and the x to both be negative, right? So what quadrant are they both negative?
3.
Quadrant 3. And which value is going to give me that? So in quadrant 3, that's going to be like, was 7 pi over 6, 5 pi over 4, and something over 3, right? So 5 pi over 3? 4 pi over 3, yeah, 4 pi over 3. So one of those is going to give me a positive rad 3, but like I said, if you put your calculator in degrees and do the inverse tangent here, it's going to give you one of those answers. But it's going to give you a positive quadrant, and you're just going to have to shift it 180 degrees. Because the two negatives is going to give you a positive, right? And the calculator is just going to go with it being a positive, and it's going to give you an answer in quadrant 1.
So it'll give you 60 degrees.
60, right?
Times.
So that's 60, that's quadrant 1, like I said.
Yeah.
And so now we need to shift it 180 degrees, right? So I needed to go all the way into quadrant 3.
So 4 times.
Yeah, that's going to be 4 pi over 3 in quadrant 3. Does that make sense or no? So my polar coordinate is going to be 2 comma 4 pi over 3. Okay, last one here. Okay, so let's go ahead. We get r equals square root of 4 squared plus -1 squared. So that's going to be r is equal to the square root of 17. Yeah. And then inverse tangent. So that's going to be something else that's going to be in quadrant 4. So this is going to be one that you want to use your calculator on, because this is not a pretty one. What do we get? Did you guys get an answer yet?
Negative 14.036 degrees.
Okay, so we say theta negative 14.036 degrees, and convert that to radian. So especially on something like this, I'm pretty sure you're not going to get a nice pretty answer. So go ahead, put in with the pi. So multiply by pi over 180.
So negative 0.245.
Negative point.
0.245.
There we go.
And then divide it.
Did you divide by pi?
No,
Is that the answer?
that's the answer, yes.
Okay. So we should have square root of 17, comma, negative 0.245 as our answer. All Alright, I'm gonna leave it there for today. I think I already sent you guys the homework